Hi students, hope everyone is fine and safe. It gives me immense pleasure to welcome you all to my new video, and today's video is about another interesting concept in the subject electrical and electronics engineering. We're going to see what is K-map, what is the structure of K-map, and what is the procedure to solve SOP and POS method using K-map, right? We've already seen what is SOP method, what is POS method, what is min term, what is max term, what are the rules and regulation in previous videos. I would recommend you people to go back to those videos so that you can understand the basic concepts of min term and max term so that you can easily understand the structure of the K-map, right? And before starting this video, we all understand what is K-map, what is the use of K-map. Karnaugh map or K-map is used to simplify the Boolean function. We know that we can able to solve the Boolean function using Boolean algebra, but Boolean algebra can be a bit difficult for complex problems. But K-map, we can use it very easily to solve the Boolean function, right? And it is a graphical representation where it is a visual way we can able to simplify the logical function. And you can able to implement K-map for any number of variables, right? But practically speaking, K-map will be very helpful for 2, 3 and 4 variables, right? So now we'll see what is K-map and what is the structure of K-map, right? So as I said before, the number of input variables, if it is more than 2, right, it will be difficult for the Boolean algebra to minimize that particular function, whereas K-map can overcome that particular difficulty. That is the greatest advantage of K-map, right? And coming to the advantages of K-map, as I said, it is a visual way to simplify the logical expression, and it can simplify in a most simplified form, and it is a graphical technique used to solve logical equation, and it is practically can be implemented for 2, 3 and 4 variables, right? And coming to structure of K-map, you got to understand what is 2, what is 3 and what is 4 variable K-map, right? If you take 2 variable K-map, right, you can see here this is 2 variable K-map where 2 variables in the sense you will have only A and B. So you'll write it as 0, 1 here, 0, 1 here, right? And then these are the positions. So you can see this is 0, this is 1, this is 2 and this is 3, right? Whereas 3 variable K-map, right, 3 variable from the name itself you can understand it is 3 variables A, B and C, right? You can see here it's A represented here, B and C is represented here. So it is 2 variable here. So it's 0, 0, 0, 1 and you cannot write 1, 0 here. Only in 3 variable and 4 variable you will have this change. Instead of writing 1, 0 here, you will write 1, 0 here and 1, 1 here, right? And this will be normal 0 and 1 because here it is only 1 variable. And while writing the position is very, very important. It is 0, 1, this will be 2 and this will be 3 because we are interchanging the values here, right? So it will be 4 here, 5 here and this is 6 and this is 7, right? So this position is very, very important to solve the problem, right? And next one is 4 variable K-map, whereas in 4 variable K-map, from the name itself you can understand it's A, B, C and D, right? So if it is A, B, C and D, you understand it's A, B and C and D, A, B, C and D, right? And now you can here it's 0, 0, 0, 1. Once again 1, 0 should be interchanged here and it's 1, 1. And it is same here 0, 0, 0, 1, 1, 0 here and it is 1, 1, right? Similarly, the positions is also should be noted here. So it's 0, 1, 2 and this is 3. Similarly, this is 4, this is 5 and this is 6 and this is 7 and this is 8, this is 9, this is 10, this is 11 and this is 12, this is 13, this is 14 and this is 15. You have to understand there will be a change here, right? And similarly here, right? So why you are writing these positions? While solving the problem, you can understand the importance of these positions, right? This is the structure of the K-map. But K-map, how will you solve the problem using K-map? You have to understand the basics of product of sum and sum of product. Product of sum and sum of product, right? I have already posted previous video about product of sum and sum of product. What is min term, what is max term, right? So this is min term, this is max term, right? And what is the rules and regulations for it, right? The same structure, say for example, if you take a two variable K-map, right? So how will you write two variable K-map? This is two variable K-map, correct? So this is two variable K-map, correct? Right? And we consider this as A and B, correct? And this is 0 and this is 1. Similarly, this is 0 and this is 1. So now, if I'm going to solve this problem for min term, min term is nothing but sum of product. So what is the rule for min term? Min term is nothing but if it is A, it will be 1. If it is A bar, it will be 0. Right, which means 0 is the complement form. So how will I write this expression? How will I write here? This A is nothing but A bar, right? And here it is A, right? Similarly, here it is B bar, and similarly here it is B, correct? Right? And the same K map, if I'm going to draw it for product of sum, right? Then what will happen? The same K map only I'm drawing. Right, C A and B. So this is 0 and this is 1. This is 0 and this is 1. But for product of sum, what is the rule? For product of sum, A is equal to 0 and A bar is equal to 1. Right? So which means this will be A and this will be A bar. And this will be B and this will be B bar. Right? So this is very, very important to understand the structure of K-map for sum of product or product of sum. Similarly, that is applicable here. Right? So if it is min term, what you will do? You will write it this as A bar and A. Right? And here what you will do? You will write it as B bar, C bar. And here you will write it as B bar, C. Here you will write it as B, C. Here you will write it as B, C bar, correct? Right? So the opposite version is for max term. You will understand very clearly when you solve the problems. So this is the general structure of the K-map, right? And this is the procedures to minimize the K-map, right? How to minimize the K-map. First of all, you got to understand what is the structure of K-map we have to use for a problem. That is, say for example, if the variable given, right, if it is only A comma B, then we will understand it is a two variable K-map. If it is A comma B comma C, then it is three variable K-map. If it is A comma B comma C comma D, then it is four variable K-map, correct? And if the input variables is not given, A, B, C is not given, from the maximum variable, right, from the maximum values, you can understand. That is, if there is only 3, then it is two variable K-map. If it is up to 7, then it is three variable K-map. If it is up to 15, then it is four variable K-map. That is what we have seen here, correct? So you can see the maximum value for two variable is 3. The maximum value for three variable is 7. So the maximum value for four variable is 15. From this value, you can understand which is the K-map which you are going to use. That is the first thing, right? And then, say for example, if the question is given like this, 0, 5 and 7. Then what we have to 0, 4, 5, 7 is nothing but the positions. You know that this is the three variable K-map. This is the three variable K-map which we are going to use, right? And you know the positions. And you have to be very clear whether you are going to use min term or max term. If it is min term, then you have to put 1 for all these positions, right? And then you have to simplify it. Whereas for max term, you have to put 0 for all these things and then you have to simplify. That is what given here, right? So if it is min term, then you will put 1 and then you will simplify, right? If it is max term, you will put 0 and then you will simplify, right? Which means in min term, you will put 1 for these positions and all other positions you will put 0. Whereas for max term, those positions has to be 0 and all other position has to be 1 and then you have to solve the K-map. Right, this is the procedure. Right, now we'll see the procedure for SOP method and POS method. Right, so you don't want to get confused with these procedures. When we see the problem in next video, you will be very clearly understanding. Right, but you have to understand this basic, this procedure. As I said, what is the first method for SOP? Whatever position they have given, say for example if it is 2, 4, 5 and 7, then you have to represent all those positions as 1 and remaining part you have to put it as 0. This is for min term. This is for SOP method, right? You can see here that is the first step. And the second method is you have to combine these ones. Wherever in all the positions you have to combine the ones. Whatever one term that is having, you have to combine it, right? How will you combine? For combining it, there is one particular rule, that is this box has to be very larger. Larger in the sense it can be 16, it can be 8, it can be 4, right? And you have to understand here, it can be only even numbers, and if it is one box is left alone, then you can consider that one box alone. Say for example you have put like 1 for all the position, but one thing cannot be combined, then that one can be considered, and apart from it no other odd numbers can be considered, right? That is what given in this point, right? So the combining of boxes can be either 16, 8 or 4, and this will be the shape. It can be a square shape or it can be rectangular shape of these forms, right? And then what you have to do, you have to map all those boxes, right? It can be from right to left or from bottom to top, right? You have to combine whatever boxes you have, right? And you have to simplify that expression, right? Overlapping can be allowed, right, for this particular box. Say for example if there is 1 and 1, you have combined it, and if there is 1 here, you can overlap this box as well. So this overlapping can be done, and then you have to write the corresponding expression for it, right? You will understand these rules when we see problems, right? This is the same procedure for POS method. What is POS method? The same method, but only one thing is different. Instead of allocating 1, what you have to do? You have to allocate 0, right? And then instead of combining all the ones, you have to combine all the zeros. That is the only difference, right? So you can see here, for POS method, you have to mention all the boxes. Whatever position they have given, all the boxes has to be 0. All the boxes has to be 0, right? And remaining boxes, it has to be 1, right? And then same, like you have to combine by using this particular method. It can be 16 or it can be 8 or it can be 4 or it can be 2. And the shape can be a square or it can be a rectangular like this, right? And what you have to do, you have to combine those boxes. It can be from right to left or left to right, right? And even if one box is left behind, then you have to combine. Only one difference here is you will combine all the boxes which is having 0 in product of method, whereas in sum of product you will combine only the boxes which is having 1, right? This is the rules and regulation for POS method, right? So today what we have seen is, we have seen what is K-map, what is the structure of K-map, what is the procedure for K-map for SOP method and as well as POS method, right? These rules is very, very important. I have created a separate video for this particular rules, because you have to understand these rules and regulation. Only then you can implement this for problems, right? I believe this video will be useful for you. Thank you, my dear students.